Okay, so today I am going to discuss about one more dynamic programming problem called longest common subsequence. The problem is not dynamic programming; it is longest common subsequence, but we will see the dynamic programming solution to this problem. Okay, so what is longest common subsequence? Suppose we are given two strings. Okay, let's say S1 is the string 1 and S2 is the string 2. Okay. For example, let's say S1 is polynomial and S2 is exponential. So we have to find out the common subsequence. This problem has is very important for DNA sequence matching or uh, flag detection from a long text file. We can match what are the same text taken together. So this type of things can be done. So let's see how we can solve this in very easy way. Okay. So we have a dynamic programming solution for this. What we do in every dynamic programming problem, we start with the how the last step is performed. Okay. Let's say this problem has a name. I am taking longest common subsequence, so we can write LCS. Okay. And that is the string S1 and S2. What is the length of this? S1 has length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it has length 10 and S2 has length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Okay, so we have to compare basically uh, string of length 10 and string of length 11. So I can write S10 and S11. Okay, this is S1, this is S2. Okay. Now we can simplify this thing like this S1, this first position is stand for this first string and second position for second string. So this writing S1, S2 inside this is basically redundant. So we can omit this also. Okay, we can omit this and we can focus on the length. These are the actual parameter. This 10 means the 10 character of the first string and this 11 means 11 character of the second string. So how the last step is done, that is our concern. Now we have to find out longest common subsequence between a string of length 10 and a string of length 11. Now come to the last character. Okay, this L and this L. How many options are there? This character may be a match or maybe a mismatch. So it may be a match or mismatch. If this is a match, is it going to contribute inside the common subsequence? Yes. If it is a mismatch, is it going to contribute in the common subsequence? No. So depending on whether it is a match or mismatch, we are going to write this recursion. So if this is a match, what we will do? We will we will chop one character from both the string and we will continue the longest common subsequence over the remaining string. So that option can be written as first I have to write max or min. It is a longest common subsequence, so I have to write max here. And what are the option? How many sub problems are there? So there are cases. For example, suppose there is a match. So we are going to chop one character for both from both these substring. So it will be LCS between string length 9 and string length 10. Okay. I have reduced one character from both the string, and one character is selected. Okay, this is inside. This is going to be inside the common subsequence. So I am writing +1 here. What are the other option? If it is a mismatch, then we can compute longest common subsequence in two ways. First option, we can chop one character from the first string, or we can chop one character from the second string. We don't know which option will give us the longest common subsequence. So I will consider both the option and take the max. So I am writing here in this way, LCS of 9, 11. This is one option. I have to add nothing because no character is matching. And another option will be LCS of 10, 10. These are the three options. Among these three options, which one is maximum? Whatever is maximum, that is going to be the solution of longest common subsequence. Okay, this is the recursion. What is the stopping condition? Stopping condition is LCS of, if it is a empty string, first one is empty string, and second one is whatever it may be, its value will be no common subsequence, 0. Okay, similarly LCS of any string and empty string is also 0. Okay, so this is a long recursion. If we compute the recursion, that is going to become exponential. So we have to go for memorization. Okay, how we will do memorization? We have to create a memorization table for that. So let's draw the memorization table. Let's say I have POLY. Okay, memorization table will be computed over all possible values. Okay, so what are the sub problem? It will be LCS 0 0 0 1 1 0 1 1. So there are two variables. It is going to become a matrix. Okay, matrix of size 10 cross 11. We will add one polynomial. Okay, it is written here, and I am going to add one more row and one more column for empty string. Okay, there is nothing. So, or we can remove this. There is nothing. Okay, nothing is there. Now let's write exponential here. Okay. Now, how we compute this memorization table in dynamic programming? Recursion always look like we are going to compute a top-down tree, but not in dynamic programming. We always compute in bottom-up manner. Okay, so this is our LCS, two variables. Okay, so we will start with LCS 0 0. So what is the value of LCS 0 0? It is basically we are comparing empty string with empty string. So its value is 0. If I am comparing empty string with this P, it will be 0. Empty string with PO, it will be also 0. Okay, so this first line is going to be all 0. These are actually stopping condition. Okay. Yes. So similarly, in this line also, we are comparing with empty string. So common subsequence value is 0. Okay, now what will be this value? This is 1 1 position. So I have to compute LCS 1 1. How to compute? I have this recursion. Okay, so I have to look at these three position. I am looking for 1 1 position. So I will go for 0 1, sorry, 0 0, 0 1 and 1 0, these three positions. If these corresponding characters are matching, E and P are matching, no, not matching, so this option will not execute, otherwise this option will do. So if there is a match, we will add 1. If there is a no match, then we will add nothing. So these three values are can be found in the top left corner or top or left. Okay. We are talking about LCS 1 1. This is LCS 0 0. This is LCS 0 1 and this is LCS 1 0. Okay. So these three value, there is no match, so we don't need to add 1. So max among these three, 0 is 0. Got it? Now repeat this in every position. So in this position, E and O are not matched. Max among these three, 0. E and L not matching. Max among these three, 0. So similarly, this is 0, 0, 0, 0, 0, 0, 0. What does it mean? It means simply if we are taking two strings, one is polynomial, another one is E, then there is no common substring. Common substring is 0. So now let's go this. For x, these three, there is no match, so this will be 0. There is no match, x and O are different, so this is also 0. X and L different, so this is also 0. This is 0, 0. There is no x in fact, so I can write all these things 0. Okay, now come to P. P and P is a match. Okay, so I have to add 1 with this diagonal position. 0 plus 1 is why? Because of this rule. If this is a match, then you have to one character reduce from both the string. So I have to add 1 with this 0 and 1 0 0. What is the maximum among that? 1. So this is 1. Now repeat this thing. Here there is no match. P and O are different. So what is the max between 1 0 and 0? So this is 1. Now this is going to be 1. Okay, because max will become 1 for all the cases. Now continue in this way. O, this is 1. Why 1? Because max among 1 0 and 0 is 1. Now O is matching here. Matching here means we have to add 1 with this diagonal position, so it is going to become 2. Now it will be 2 for all the elements. Okay. So similarly, compute the remaining value. We have n here, so we have 1 here, max is 2, max is 2, no matching, so no need of increasing the thing. N here is the match, so I have to add 1. Okay, so now all this value will be 3 3 3 3 3. Now the next value is I. This is 1, this is 2, this is 2, no matching so far. This is going to be 3, this is going to be 3 3 3, and then I is a match, so it is going to be 4, and it is also going to be 4. Okay. Now n again, so this is 1, this is 2 2 2, this is 3. Okay, why this is 3? Because n is a match, so I am adding 1 with this diagonal position, so 2 become 3. Okay, so 3 3 and 2, max among this is 3, so this is 3. Okay, now 3 will continue, 3. Now here we have 4. So this is 4, this is 4. Now T, for T, it is 1, this is 2, and then 2, 2, 3, 3. Is there any T? No. So I don't need to bother about anything. Just write all these values. I, 1, 2, 2, 2, 3. Is there I? I is here. 3, 3. Now I is a matching. 3 plus 3, 3 plus 1, 4. Max among 3, 4 and 3 is so 4. So here it will be 4, it will be 4. Now I have two more characters. A, for A is all going to be 1, 2, 2, 2, 3, 3, 3, 4. Then A is a match, so 4 plus 1 is 5, and this is going to be 5. For L, it is going to be 1, 2, 2, 2, 3, 3, 3, 4, 5, and then 6. Okay, so length of the longest common subsequence is 6. What are the characters? What is the output? So this, where, how we started from the 0 and we got 6. How we got this 6? Every time there is an increment, one character was selected. So there may be multiple options. So let me backtrack these things. You can put some arrow or some symbol or some flag to what are the character we have to select. So main thing is you have to check where this 6 became 6 from the 5. Okay. So this 6 became 6 from the 5 from this last option, and the corresponding character is L. So let's write L. It is going to be the selected in the output. So similarly, previous element was from 4. So A is going to be selected, I is going to be selected, okay. And before that it was 3, so it was 3, 3 became 2 in this position, so you can select this one, this N, okay. And this 2 became 2 from 1 in at that position, so you can select this element, okay. And 1 became 1 from the 0 at this position, so this is going to be selected, this is going to be selected. So I got PONIAL. So this is the common subsequence between polynomial and exponential. Now this answer may not be unique. There are 6 characters, 1, 2, 3, 4, 5, 6. Yes, 6 characters is there. Okay. So this answer may not be unique, means you can find other sequence also. Okay. Others, but the length will be 6. What is the complexity of this dynamic programming algorithm? Complexity will be, I am computing a table of size m into n, so complexity is order of m into n, where m is the length of the first string and n is the length of the second string. Okay. Now this problem can be applied in many ways. For example, find out the longest palindromic subsequence inside a string. So what you have to do? Take S1 as that sequence, and in S2 put the sequence in a reverse. Reverse the string and put into the S2. Now compute longest common subsequence. You will get the longest palindromic subsequence. Okay. So that's all in longest common subsequence.